Right now, somewhere on Earth, someone is pointing a laser pointer at the night sky. It feels powerful. A thin red line stretching up into infinity. So what if every single person on the planet did it at once, all pointed at the moon? Let's set the rules. 8 billion people. Standard handheld laser pointers, the kind you'd find in a classroom or a cat toy. All aimed at the same lunar target, at the same moment. What would actually happen up there? Start with the trip itself, because this is where the whole idea runs into trouble almost immediately. The moon sits about 238,000 miles away. A laser beam doesn't stay a tight little dot over that kind of distance. It spreads out, the same way a flashlight beam widens the farther it travels from the bulb. Physicists call this divergence, and even a laser built to be as tight as possible will have widened to cover an area many miles across by the time it reaches the moon. Your perfectly aimed dot wouldn't land as a dot at all. It would arrive as a faint, diffuse smear, scattered across a patch of lunar surface roughly the size of a small country. Now stack 8 billion of those smears on top of each other. You might expect that to add up to something dramatic. It doesn't, and here's why. Most cheap laser pointers only put out somewhere between 1 and 5 milliwatts of power. Multiply that by 8 billion, and you get a combined output somewhere in the range of 10 to 40,000 watts. That sounds like a lot, until you compare it to what's already hitting the moon every single day for free. Sunlight delivers something on the order of over 1 trillion watts of energy across the illuminated lunar surface. Every laser pointer on the planet, combined, wouldn't even register as a rounding error next to the light the sun is already dumping onto the moon's face, second by second. This is the part worth sitting with. You didn't fail because 8 billion people isn't a lot. You failed because a laser pointer was never built to punch through 238,000 miles of space and still matter once it got there. It was built to be visible in a dark room, not to compete with a star. So here's the twist, and it's a real one. NASA has actually done something close to this experiment, just with far more precision. Apollo astronauts left small mirrored panels on the lunar surface, called retroreflectors, designed specifically to bounce a laser beam straight back to Earth. Scientists still use these today, firing a single, powerful, carefully focused laser from an observatory, aiming it at one of these panels, and timing exactly how long the light takes to return. That single beam, built by engineers, aimed with extreme precision, using far more power than any laser pointer, still arrives back so faint that observatories need extremely sensitive equipment just to detect a handful of returning photons. If one professional-grade beam barely survives the round trip, 8 billion scattered pointer beams were never going to leave a mark. There's a second, quieter twist hiding in this question too. If you swapped out those pointers for something powerful enough to actually matter, an industrial or military-grade laser, you wouldn't need billions of people at all. You'd run into an entirely different problem. Pointing any high-powered laser at aircraft or satellites is treated as a serious safety hazard here on Earth, precisely because even far weaker beams than that can blind pilots or damage delicate sensors thousands of times closer than the moon. The danger was never really about reaching the moon. It was about what a beam like that could do to everything in between, long before it ever left the atmosphere. Which brings you back to that one person, standing outside, pointing a thin red line up into the dark. It feels like it's reaching something. It isn't, not in any way the moon would ever notice. But somewhere above that same sky, a research team's single, carefully aimed beam is doing exactly what 8 billion pointers couldn't, bouncing off a mirror an astronaut left behind decades ago, traveling 500,000 miles round trip, and coming home as little more than a whisper of light. The moon was never impossible to reach. It was just never going to notice the difference between a whisper and a shout, unless you sent the right kind of light in the first place.